Hello everyone and welcome back to Code with Goldencat. Today we'll be creating our very own bank application. So let's begin. By the end of this video, you should have a working web application that looks something like this that allows you to register some users here. So if I register two users here first with the name Goldencat and password 123 and then register another user with the username as happycat and password 123. Now I'll log in with my Goldencat credentials and I'm greeted with a dashboard page, which has three options: deposit, withdraw, and transfer money. By using deposit, I can deposit some amount of money into my current account. As you can see, the current balance is shown as $0. So if I add 100 here and then click on submit, the current balance becomes 100. Now I can also withdraw some amount from this. So if I type in 33 and then click on submit, the current balance becomes $67. And I can also transfer money to another account. If I type in happycat, this is the account that we just created, and then type in $10 as the amount, click on submit, the current balance now becomes 57. Now you can also see all of these transaction log history in the transactions tab above. Here, all the money that was coming in to the account is shown in green color, and the money that was going out of the account is shown in red color. And we can also see the transfer out to happycat. Now, if I log out from this and then log in with my happycat account, password 123, you can see the current balance for this account is $10. And in the transactions log, there is a transfer in from Goldencat. Now, without further ado, let's dive straight into coding. Now, before we can start coding, we first have to clone this repository. You can find the URL for this repository in the video description. So we'll go to code and then copy this. Then go to our working directory and open command prompt and then type in git clone and then the URL. This would clone the repository. And now I can open this project in IntelliJ. As always, if you go to Git tab, you can see we have two branches here, end and start. The start branch has the skeleton project that we'll be using in this video, and the end branch has the finished project. So if I check out the end branch and then open src folder, you can see it has all the files that we'll be creating in this video. Now let's switch back to start branch. Now for this project, we'll be using the Spring Boot framework for the backend, Thymeleaf for the frontend, and for the database, we'll be using MySQL database. Now let's see what we are getting back in our skeleton project. If I expand src folder, here I have the bank app application, which acts as the starting point for this application. Then in the resources section, I have a SQL script that we'll be using to create a database in our MySQL database. Then in the template, I have a couple of templates for dashboard, login, register, and transactions log table. And then in our application.properties, here I have defined a couple of properties for connecting with our MySQL database. After that, we can see we have this pom.xml here, and the only dependency that we are using here that is new is the MySQL connector. Now this dependency allows us to connect to our MySQL database. Now that we understand what we are getting back in our skeleton project, let's dive straight into coding. So first, we have to set up our MySQL database. For that, we can open the SQL script text file and then copy this command. Then we'll open MySQL Workbench. If you're not sure how to set up your MySQL Workbench, then I have provided a link to an earlier video in which I have shown you how to set it up. You can follow that guide. Now we can open this local instance, type in the password test@123. Now this password might be different for you. Then run this command, create database bank app db. And if we refresh here, you can see that the database has been created. But right now it doesn't have any tables in it. But you don't need to worry about that because our application would automatically generate the tables. Now let's move back to IntelliJ. Now let's collapse all of these files and define a couple of folders here. The first folder would be config, then we would have model, then controller, then service, and finally repository folder. Now first, we'll create a model here with the name, account, and declare it as entity. Now this class would have following properties: private, long, ID, and we'll make it as the primary key, right? Generated value, strategy equals to generation types dot identity, then private string username, private string password, and private big decimal balance. After this, we'll also define a couple of more properties. So the first property would be private list transaction. We'll define this class in a couple of moments and name this as transactions. Add at the rate one to many relationship on this column mapped by account. After this, we'll also define another property that we don't want to be mapped in the database. So we'll mark it as transient property, private collection, question mark, extends granted authority, and authorities. So always remember, if you mark a property as at the rate transient, the column for that property would not be created in the database. Now once this is done, we'll create a couple of constructors here. We can right click here, then click on generate. Then first click on select none, and that would create a default constructor. After that, we'll create another constructor here with all of these properties except for ID. Then click on OK, and that creates it. Once that is done, we'll also create getters and setters for all of those properties. So we can right click, go to generate, and then click on getter setter, click on OK. And that's it. We are done with our account class. Now we'll create another model here with name transaction. And again, we'll mark this as entity. Now this class would have the following properties: private long ID, private big decimal amount, private string type, private local date time, timestamp. We'll mark this property as ID at the generated value, strategy equals to generation type dot identity, After that, we'll create a property here, private account, account at the rate many to one at the rate join column name account underscore ID. So we want this property to be mapped with the ID property of account table, this one. Now this model class would be responsible for storing the transaction logs. Once this is done, we'll also create a constructor here, first with no parameters, then create another constructor here with all of these parameters except for ID. Click on OK. And now we'll create getters and setters for all of those properties. We can select all of them, click on OK. And that's it. We are done with our model class. Now that we are done with our model classes, let's create our first repository class. So we'll name this class as account repository and we'll select it as interface. Now this interface would extend JP repository with parameters account, comma, long. And this would have a method optional account as the return type, find by username, string username. Now let's import this optional here and save it. After this, we'll also create another repository file here. Select interface and then give it the name transaction repository. Now again, this repository would extend the JP repository with parameters as transaction, comma, long, and then list, comma, transaction is find by account ID, long, account ID, and that's it. We are done with our repository part. Now after this, we'll create our service files. So the first file that we'll be creating would be account service. Now we'll mark this as service using the annotation at the rate service. And this would have dependency injection of password encoder. And we'll also implement a class here, user detail service. Now after this, we'll inject another dependency, private account repository, and then define a method here, public account, find account by username, string username, return account repository dot find by username dot or else throw a runtime exception saying account not found. After this, we'll create another method here, public account, register account that we'll use for registering an account. Now, this method would take in two parameters, string username, comma string password. Now, if account repository dot find by username contains that user is present, then we'll throw a runtime exception. Username already exists. After that, we create account object here, new account, and then set its username to username, then set its password to password encoder dot encode, then password, and set the balance to big decimal dot zero. After that, we'll return account repository dot save account. Now that we have the method for registering a user, we'll create another method here, public void for deposit. Now this method would take in two parameters, account and amount. Now first, we would set the balance of the account dot get balance dot add amount, account repository dot save account, and then create a transaction here, new transaction, and give it value of amount deposit, local date time dot now account. After that, we can type in transaction repository dot save. We'll also need to inject this one. We can type in at the rate autowired private transaction repository, and it works now. After that, we'll also need to define a method for withdrawal, which would take in two parameters, account, and big decimal amount. Now, if account dot get balance dot compare amount is smaller than 0. So if the withdrawal amount is more than the amount that's already present in the account, then we throw a runtime exception saying insufficient funds. If not, then we can simply go account.setBalance, account.getBalance, add dot subtract amount, and account repository dot save account. After that, we'll again need to define a transaction here. We can copy this and just change this deposit to withdraw, and we can leave all of those as it is. Then call transaction repository dot save and transaction. Now after this, we'll define a method public list transaction get transaction history, which would take in account as the parameter and return transaction repository dot find by account ID, account dot get ID. Now let's import this. Now define another method here, public user detail space load user by username, string username throws username not found exception. So we are creating this method for login and logout purposes and add at the rate override. Now in this method, we can type in account equals to find account by username if account equal to null, then with row a username not found exception saying username or password not found. Otherwise, we will return a new account object with values account dot get username, comma account dot get password, comma account dot get balance, get transaction, and finally authorities. Now we'll define this method now. So we'll type in public collection extends granted authority. The name of the method would be authorities, which would return arrays dot as list new simple granted authority user. Now we are getting back an error here. So we have to go back to our account class and then add here implements user details, and that would resolve the issue. Now after this, we'll define another method here, public void transfer amount, which would take in three parameters: account, from account, comma, string to username, comma, big decimal amount. Now if from account dot get balance dot compare to amount is smaller than zero. So again, if you're transferring some money to another account, but the amount of money that is being transferred is more than the amount of money that is present in the account, then we again throw a runtime exception. So we can type in throw new runtime exception saying insufficient funds. After this, we can define to account equals to account repository dot find by username to username or else throw saying recipient account not found. Now, if we do found the account, then we would deduct amount from a current account of set balance from account dot get balance dot subtract amount, and then account repository dot save from account. And then add balance to the to account, account repository dot save to account, and then create the transaction records transaction debit transaction equal to new transaction amount, comma, transfer out to plus to account dot get username local date time dot now, then from account, and we'll save this record. After that, we'll also create a credit transaction record. We can copy this, change this debit transaction to credit transaction. The amount would remain same. Instead of transfer out, we will write transfer in, and from account, and instead of from account, We'll use to account. Let's change this to credit transaction. And that's it. We are done with our account service. Now after this, we'll define the controller class and we'll name this as bank controller and mark it with annotation controller, then inject a dependency of account service and add the get mapping first or slash dashboard public string dashboard model string username equal to security context holder dot get context dot get authentication dot get username. After that, we'll use account class, account service dot find by username model dot add attribute. Okay, let's add this again. Attribute account comma account return dashboard. After this, we'll define another get mapping for registration page slash register public string show registration form, and this would simply return the register page back to the user. After this, we'll create a post mapping for register endpoint when the user is trying to save a new user. Public string register account. This would have the following parameters: request param, space, string, username, comma, at the request param, space, string, password, comma, model, try, account service dot register account, username, comma, password, return, redirect, login, and then define a catch block here, runtime exception, e model dot add attribute, error, comma, e dot get message, and return register. After this, we'll again define a get mapping for giving out the login page public string login return login page. After this, post mapping for our deposit endpoint, public string deposit at the rate request param with decimal amount string username equal to security context holder dot get context dot get authentication dot get name. Then account space account equals to account service dot and by username account service dot deposit amount and return a redirect to dashboard. After this, another post mapping for withdrawal endpoint, public string withdraw at the rate request param big decimal amount comma model space model string username equal to security context holder dot get context dot get authentication dot get name account account equal to account service dot find by username. Then in a try catch block account service dot withdraw method account comma amount, then add a catch block runtime exception model dot add attribute error comma e dot get message model dot add attribute account account and then return dashboard. If not, then we return a redirect to dashboard again. After this, at the rate get mapping for getting back the transaction logs slash transaction public string transaction history model string username equal to, let's copy this part and then type in model dot add attribute transactions, comma, account service dot get transaction history account, and then return transaction view. After this, we'll also need to define a post mapping for transfer. Public string transfer amount at the request param string to username, comma, at the request param big decimal amount, comma, model, and then use the code again for getting back the user account. Let's change this to from account, and then create a try catch block account service dot transfer amount from account, comma, to username, comma, amount, catch, runtime exception, e, model dot add attribute, error, comma, e dot get message, model dot add attribute, account, comma, from account, and then return dashboard or give a redirect to dashboard. And that's it. We are finally done with our controller class. Now we are only left with creating our config class. So let's do that now. We'll name this as security config and we'll add annotations at the rate configuration and at the rate enable web security on it. After that, we'll type in auto-wired account service space account service at the rate bean public static password encoder return new bcrypt password encoder. Now, if you're not sure what all of this means, then I would suggest you watch the earlier videos because I've already explained all of these concepts in detail. After this, we'll again define another bean here, public security filter chain, security filter chain, and let's import this first. HTTP security, HTTP, pose exception, HTTP dot CSRF, CSRF, CSRF dot disable dot authorize HTTP requests auths auths dot request matcher slash register dot permit all dot any request dot authenticated. Then let's close it. After this, we'll define form login form dot login page slash login dot login processing URL slash login dot default success URL slash dashboard comma true dot permit all. After this, for logout dot invalid HTTP session true dot clear authentication true dot logout success URL login logout dot logout request matcher new and path request matcher slash logout dot permit all dot header header dot frame option frame option frame options dot same origin, and then return http dot build. After this, we'll define one last method, public void configure global authentication manager builder auth throws exception auth dot user detail service account service dot password encoder, and that's it. Now we are finally done to see our application in action. Now let's run this application. So we can run it here. And we can access it on port 8080, and it's working fine. Now let's register a user here, Goldencat 123. Now if I again try to register Goldencat, it should give me an error that user already present. So let's register a different user, happy cat 123. And let's check if our login functionality is working as expected. So I'll type in ABC and login, and it gives me an error saying invalid username or password. So that is also working. Goldencat123, and we can see our dashboard. Now let's deposit some money into this, and the current balance becomes 123. Now withdraw some money out of it, and the current balance becomes 100. And if I try to withdraw $144, which is more than the current balance, it gives me an error saying insufficient fund. Now let's also transfer some money to Happy Cat, 14 bucks. Click on submit, and the current balance is being updated. Now if I go to my transaction logs, it's also working as expected. I can see all three of those transactions. And if I do incognito mode and then run another instance of localhost and log in happycat123, we can see the current balance is 14 bucks and the transaction transfer into Goldencat is there. Now, if we also look into our MySQL workbench, let's refresh this. You can see it has two tables here, account and transaction, and both of them has the required data. Now, this project can act as a really good starting point for any banking application. You can also use this as your final year project. You just have to add more capabilities to it, or you can use it as it is. That totally depends on you. As always, we'll end this video with a quote that says, "We cannot solve problems with the kind of thinking we employed when we came up with them." Thank you for watching and have a great day.